my name is Doris Valencia Pico, and I am here to present to you step by step the process of generating acetyl CoA from pyruvate. So here I have the mitochondria. We know that pyruvate is a 3-carbon molecule, which 2 pyruvates are produced from glycolysis. This pyruvate production can be from 2 different pathways, one anaerobic and the other aerobic. So in this presentation, we're going to focus on the aerobic pathway. In order for the pyruvate to cross the mitochondria, it has to be in an environment full of oxygen. So basically, when the pyruvate crosses the mitochondria, it becomes acetyl CoA group. We have the 3-carbon molecule of pyruvate is converted into 2 carbons acetyl CoA. So we have 2 carbons, and then one of these carbons is broken down into carbon dioxide. So basically here the carboxylated molecule becomes carbon dioxide. This process happens because of an enzyme called the pyruvate dehydrogenase. This is the one that catalyzes this 3 molecule into 2 and gives us 1 carbon dioxide. Then we have this 2, which in turn adds NADH, which therefore is converted into NADH. This is a irreversible process, so this cannot go back. Once it starts happening, it happens. And then after this acetyl CoA production, the Krebs cycle occurs. So in order for this process of pyruvate converting into acetyl CoA, it happens through this PDH complex, or the pyruvate dehydrogenase complex, which is composed of 3 enzymes: E1, E2, E3. E1 is also called pyruvate dehydrogenase. And this enzyme has an important vitamin, which is called the thiamine, or vitamin B1. This is crucial because this binds to 2 phosphates, creating the TPP, one molecule, and another molecule of TPP. TPP is a thiamine pyrophosphate molecule. This reacts with pyruvate, and a carbon is removed, leaving 2 carbon acetyl groups. Thiamine then gives up 1 carbon group or acetyl group to E2. This is helped by lipoate. I forgot that this enzyme 2 is called dehydrolipoamide acetyltransferase, and this has the lipoate, which transfers this this lipoatase has a sulfur two sulfur or disulfate molecules. This sulfur reacts with the TPP, which pulls the carbon chain. So one becomes ethyl and the other one gives up the acetyl group, adding a CoA, acetyl CoA. This CoA reacts with acetyl group, and this gives two carbon fragments of this CoA, making acetyl CoA. So this is how we start the making of acetyl CoA. In enzyme 3, which is called the dihydrolipoamide dehydrogenase, this lipoate, which has two ethyl groups, the SH groups, SH, they travel here, they get transferred to this area where where FAD turns into FADH2. This process also basically the hydrides become attracted to this FDA, so it turns into FDAH2, but it also needs a little help of the NADH to get control over those hydrates. This puts so this process here, this complex, is very regulated process. It is regulated by one enzyme here and another enzyme here. This enzyme here, it's called the pyruvate dehydrogenase kinase. This basically inhibits this whole complex into making too much ATP. Let's say the body has a lot of ATP and doesn't need any more energy. So this the pyruvate dehydrogenase kinase inhibits this by putting a phosphorus group here. So this whole complex is inhibited. Now, the other enzyme that regulates this whole complex is called the PDH. The PDH basically removes this phosphate group. It removes it. Therefore, it causes the complex to produce more ATP when the body needs it. So now this PDH is basically the one that says, hey, go ahead and make more acetyl CoA so we can produce more ATP for the cell to generate more energy. This is influenced by insulin and calcium. This is important because when there's too much sugar in the cell or around the cell, insulin comes in and regulates this process, as well as calcium. Very important to keep in mind is thiamine here, because when people lack of thiamine, in the case of alcoholic people, they start suffering from neurological problems. So this is my explanation. I hope it's clear, and thank you for your time.